Good day, professional, and welcome to another class of quantitative analysis, where we shall be discussing, where we shall continue with our discussion on linear programming method, on linear programming rather. In our previous class on linear programming, we said the linear programming is a mathematical model which we use to solve some financial issue that involve the constraint of items. And we also look at the various elements of the linear programming. We said basically that linear programming solves two problems, either maximizing the profit or to minimize the cost. And a company tends to solve a thing at a time. They don't solve the two at once. We look at the essential of the linear programming model, which we said it includes the limited resources, objectivity, linearity, homogeneity, and the divisibility. We also look at the uses of linear programming, which include the budgeting, capital budget transfer pricing, as well as the relevant cost. And we look at the steps that involves in solving the linear programming problem, which involves stating the objective. Is the objective to maximize profit or to minimize cost? And we said after that, we're going to state the structural constraint, which is the constraint. What are the limited activities that what are the resources that we want to use to achieve our objective that has been stated? And that is what we are going to formulate in the constraint. After that, we will draw a graph to actually demonstrate the feasible region, which is the solution variables. After which we're not going to calculate or we solve our optimal production plan. And in our class yesterday, under our text, our understanding, we were able to do that of using the linear programming method, and we also use a graphical method, as well as we also calculated out of the shadow price, otherwise known as shadow cost, which is said it is the cost of adding additional 1 unit to the variables. Having said that, yeah, let's quickly talk on slack before we move to, actually, we need to talk on slack basically under the simplest method because it is a slack that is being added to the, what do we call it? When we make mention of a slack occur when the maximum availability of resources is not used. That is the excesses of material, the excesses of resources that we did not use. That is what we call slack. Slack is just a gap, a space that was not utilized. So slack is just the amount by which the resources is what is underutilized. Is the amount by which the resources is what underutilized, and it occurs when the optimum point does not fall on a given resources line. At times, you can see when we are calculating our optimal production level, at times it will not even fall on the aspect that we expected. So that is why we usually have our slack. But let us note that if at the optimal solution, the resources used is equal to the resources available, we will say there's no slack and there's a binding constraint. Binding constraint means the limited resources are together, they are binded, and therefore there's no slack. When something is tight, is there a space? The answer is no. That's why we said there's no slack. And there, the shadow price will also have to be calculated. Note that when we calculated our shadow price, it always affects the first equation, and it is by us adding additional 1 unit to the total available resources and not all the what equations. Let us note that. Yeah. From there, we go to what happens if the objective is to minimize cost. What we have observed is maximizing the productivity, which is we maximize contribution. Contribution therein is regarded as what? Profit. When we maximize the profit of the organization. Then what now happens if we are to minimize cost? Let us note that we follow the same step as what we have done. Then we now check the constraints. Are they less than or they are greater than? Yeah, because in minimization, we will need to check the cost. Are you reducing the cost or you are maximizing the contribution? Not that in everything, because we want to minimize the cost, we now say it should be greater than. No, we need to check the constraint. Are we using a greater than constraint or we are using a less than constraint? You already know that whenever we are maximizing the contribution, our total resources must not be more than the available resources. But in a situation whereby the cost needs to even exceed that, what will we do? We'll be using a greater than. So if they are greater than, the region you will consider will be above the constraint. This is what I mean by that. Let us assume, whenever we draw, let's use our yesterday illustration. We draw one variable like this, we draw another variable like this, and we say this is our feasible region. Is that not? If it is a minimization, or we have a greater than sign, here will be the feasible region. If it is greater than, here, all this place will be the feasible region. We just look at which point. This is point 1 from here to year 1. Another point, we just do it like this. We just do it like this. And this another one here. That is how to calculate. That is how to find the feasible region when we are having greater than. Instead of having the feasible region inside the bracket, we'll be having it outside our diagram. That is what we need to know. And we should also note that the optimal point will be the first point you reach on your feasible region when you shift out the ISO cost function. At times, you'll be given the ISO cost function. How does the ISO cost function is? They may tell us under the equation, just like what we have yesterday. They may just give us y equal to 30. That's just for instance. When we have y equal to 30, what are we going to do? We have already drawn our equation 1. We've drawn our equation 2. But because of this y equal to 30, we now look at the 30. Let's assume this is 30. This is 20. This is 10 and 0. We now draw a straight line. That the line will be linear, will be straight. It can be at 30. It can be down here. It can be up here. It can be as close as anything. Whenever we have an ISO contribution line, our feasible region will not start from here again. It will be under here. So we should take note of that. At times, the ISO contribution line can be like this. If it is like this, when you're calculating for this, we look for an angle between here and here, 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 here. Instead of your angle to be 4, you'll be having like around 6 angles. Yesterday we used RSTU, we used 4. Suppose we are having an ISO contribution, we may have like 6 points, RSTU, VW, like that. So we should just pay attention to that. But I'm not really expecting ICAN to give you that at this level. However, you need to be aware of it. That is that on that. What we didn't explain yesterday. Now, let's go to another method of solving linear programming problem. Remember that we said basically we have 2 types of method in solving linear programming. You see the other one being introduced, which we called simultaneous equation. I told us that we use simultaneous equation in order to get our perfect optimal solution point. It is not a method. For you to use your simultaneous equation method, you would have already drawn your graph. It is after drawing your graph that you can now include simultaneous equation to just solve for your what? Your optimal production level. So simplest method is the other one. It interests me to inform us that simplest method is such a complex method. But if you really pay attention, you will get it. Both simplest and graphical aims to solve the same problem. Simplest method. Okay, in practice, most problem usually, simplest method is used for a variable that is more than two. More than two variables. You know, under your graphical method, graph only have two variables. Our graph is like this. Variable x and our y-axis. What if the product is three products? If you have x, a, b, and c, what will we do? Because the sample that we took on graphical was two products, A and B, and it uses three materials. What if it is three products and uses two materials? How are we going to do it? If they produce three products, we cannot say X, Y, and I put another one and call it Z. No, our graph only contains two variables. But where a company have more than two variables, we are to use our simplest method. If a question, even without telling you, if a question states that employer might manufacture three products, A, B, and C, without telling you, your mind should first go to simplest method. Please take note. Without you being told, your mindset should first go to the what? The simplest method. We can use simplest method to also solve for two variables, but graph is the best for two variables, for two products rather. But simplest method can be used for 3, 4, 5, countless. So in practice, most problems usually contain more than two variables, and consequently, they're too large to be tackled by conventional means, which is the graphical. Therefore, an algebraic technique is used to solve the large problem using what? The simplest method. And this method carried out through iterative process systematically, step by step. And finally, the maximum or the minimum value of the objective function are obtained. In simplest method do not necessarily meant for minimize or maximize. In fact, graphical, like I told us yesterday, you can still use graphical for minimization, and you can also use it for what? Maximization. Please take note of that. All right, the various terms that we'll be using under the simplest method include one, standard form. Most of what we use, we usually express them in a standard form. But the standard form that we have here is, instead of having, it's just, let me call it, is the similarity between what we did yesterday and this. And it interests me to tell us that if ICAN will be giving you a question that involves simplest method, they will just tell you to create the initial tableau or formulate the linear programming model using the simplest method. That's only what they're going to tell you. And the same process, remember what I said earlier, they are the same thing. It follows suit the same process. So there's no difference in what we have done. It is only the expression of terms that may be quite different. Okay? Excuse me, please. All right. So let's get started. Simplest method of linear programming. Okay. So let us examine a question. This one is, though, it's just quite a simple question, but this is how the question usually come. They will just ask you to express the following in a linear programming model. They will just ask us to express the following linear programming model in a standard form. That is usually what the question usually says. Express the following in a linear programming model in standard form. And if such is given, this is what they will just give to you. In this question, we are asked to minimize 3x1 plus 2x2 plus x3. Minimize 3x1 plus 2x2 plus x3. Subject to what? Subject to x1 plus 3x3 less than or equal to 10. Then 2x1 plus x2 plus 3x3 less than or equal to 40. And 3x1 plus 2x3 is less than or equal to 20. And our x1, our x2, our x3 will be greater than 0. Who can express this for me in a sentence form, just as I explained in our last class? Can somebody explain this to me? Who can express this for me in a sentence form? Anybody? Am I having hope? Hello? Hello? Anybody in class? Hello? Are we together?
Yes, sir.
Okay, can you express this for me in a form? I'm waiting. Let's assume you have something like this. How can you express it for me in a statement form? I'm waiting.
I don't understand what you mean.
We have an equation like this. Yesterday, when we have an equation, I explained to us that this equation that we're having, this is how the statement is. Express it in a statement form. That's my question. Excuse me, please. Is the recording still going?
Yes, sir.
Please check.
Yes, it's still going. Still record.
Okay. All right.
In progress.
So can we exit for me? Hello, please, can you see the screen now? Hello? Hello?
Yes, sir.
Ah, Madam Otun, are you still the only one in class? Others didn't join. Hallelujah. Thank you so much for that. My system just powered now. So they just restored the light. That is why I changed the stuff. So thank you so much for being my savior for this evening. Okay, so let us continue. So what I mean, I said, can we express this in a statement form? Remember yesterday when we have a question, the question was expressed to us in a form, and from that form, we use it to we illustrated it with an equation. Then the same thing I'm asking, this equation that has been given to us, can we express it in a statement form? That's the question. How many products did the company have? What are the materials used to produce the product? Using this equation form given to us. That's my question. Is it clear now?
I don't understand you, sir.
How many material, how many products is this company has? And what are the material for such products? Do you get it or still didn't get it? Hello?
I get it, yes. I get it now.
Oh yeah, that has been my question. That's what I've been asking for. Express it. Ability to express it in a statement form would really give us a kind of edge. I'm waiting.
One material.
Is it one material? Check it very well. Let's use a company.
Two material.
So a company has two materials. Is it two or three?
Three.
Three materials. Okay. A company produces three materials. Material X1, material X2, material X3. And uses how many? A company produces three products: X1, X2, and X3. Is that not?
Yes, sir.
It's a three product, not a three material. It's a three product. And uses how many material?
One.
One material.
Yes.
Okay. So what is the material used?
X.
All right. Thank you so much for that. This form is an expression of a statement that is already being expressed in a linear form, or we call it a standard form. A company manufactures three products, X1, X2, X3. Using the material, we have just one material to produce the three products. That is why no material was given there. But the material as uses one of X1 and three of X3, two of X1, one of X2, three of X3, and the total available is 40. While we also have 3X1 plus 2X3 less than or equals to what? 20. So this is a question that has already been given And we are asked to express it in the standard form. Please sign me out. We are asked to express it in the standard form. Okay? Excuse me, please. Please hold on. Please sign me out. Sorry, please. Sorry, please. I really need to stop the person that is trying to sign in so that they will not just kick us out unnecessarily. PPFE. Oh, that's 7 p.m. now. PPFE is 7 o'clock and nobody should be available today. Nobody should use the platform. Sorry, is PPFA for ATS2? Sorry, somebody in ATS2. Is PPFA for ATS2?
Yes.
I didn't get.
Yes, PPF is yes. Financial account.
Financial account, okay.
But I don't think you are meant to have it. Okay.
Do you have it now or 7 o'clock?
Yeah, okay.
Please hold on. Just let me resolve the issue. Not to worry, boss. I'm only setting up the class for 7 p.m. Okay, sir. So you'll be having PPFA by 7 o'clock. Okay. Apology for that. Whenever I see this thing and we didn't resolve it, we just end up being kicked out of the class without even telling someone. So I'm sorry for the short break and apology for taking your time for that. So let's continue, please. All right. So what we really need to understand under, what do we call it? What we need to understand in simplest method is this introduction of a Slack variable. Let me show you how it goes. I'm really interested to use the formal stuff that we are using. And that is the beauty of simplest method. And what they will tell you is express it in standard form. Slack variable is the one they are calling a standard form. Please be aware. Simplest. Oh, sorry. Our recording. So it is Slack variable that they are calling simplest, that they are calling standard form. And this is how it comes. First, write out the equation that you are given, okay? Whenever you have, what is the equation? Is minimize 3x1 plus 2x2 plus what? x3. So you have minimize z. Z is your solution variable. Whenever you have, you see that they even put z. Z is your solution variable. Under simplest method, we tend to use Z under simplest method for what? For solution variable. Okay, so please, let's take note. So minimize Z equal to 3x1 plus 2x2 plus x3. 3x1 plus 2x2 plus x3. Is that taken? Then you will put, remember, objective function. This is our objective function. Okay, you now write your constraint. Your constraint is what they call subject to. Then I always advise, let everything be under the same stuff that we have it. Let everything just be under that same stuff. Okay, the first one is your subject to is 2x1. We are going to rearrange them. Just don't worry yourself, okay? We have 2x1. Let's first write this one. We have 2x1 plus 3x3 plus 3x3 less than or equal to 10. x1, x2, 2x1, x2 plus 3x3. Then the next one, 3x1 to x3. And the next one, 3x1 plus 2x3. Okay, that's all. Then our negativity is that x1, x2, x3 will be what? Okay, we can write it x1, x2, x3 will be greater than or equal to what? 0. Now, this is the standard.
Hello?
Yes, ma'am.
This one, constraint, is x1. There's no 2 in front of it.
I didn't get that.
The first one, the constraint is just x1. There's no 2 in front of it. No kind of.
The first one, x1 plus 3x3. This is the first one.
You wrote x2, x1. Instead of
This is the objective function. What we have here.
In the question, sir, the first one does not have 2. It's only x1. Does not have 2.
Okay. The first one do not have 2. It's only x1. Is that what you're saying? God bless you. Thank you so much. Thank you. Thank you, thank you, thank you. Thank you for that. That's a good observation. All right. So what we just have to do here is just say the standard that is just say add slack variables. How many products do we have? We have 3 products. So we add slack variable S1, S2, X3 to the constraint. To the what? To the constraint. So this is how it is. The first one, we just rewrite all the X1 to come under the same stuff, all the X2 also to be on the same spot, and all the X3 also to be on the same spot, as if they are in the same line. Okay, as if they are in the what? Same line. You can say initially it is the constraint that we are adding it to. But because of the standard form that they requested, you can just say, you can restate your objective function and say minus z equal to 3x1, 3x2, and x3. I want to be saying it. 3x1 plus 2x2 plus x3. Okay. So that is your, what do we call it? This is objective function. From this objective function, just add your slack 1, slack 2, slack 3. That's all. Your slack 1, your slack 2, your slack 3. That is all. Okay. Oh yeah, let's follow that trend. Subject to, we are following that trend. What is your first subject? Your x1, is that not so? You have your x1 plus what? Plus what? Hello. Your x1 plus what? Hi. Why are we making the class with today? What's going on?
Yes.
What is yes? Why are we making it so dull today? That's my question. Hello.
Sir.
Our x1 plus what?
3x.
Plus 3x. Now that 3x, is it x3 or x2? Go back to the information given to us. You see that it is x1 plus what? 3x3. Is that not?
Yes, sir.
So go back to your equation. You come under here, we have 3x3. I'm coming. Okay. I am what? I am coming. We have x1 plus 3x3. Is that taken? Then add your slack variable plus x1. The other one, 2x1 plus what? 2x1 plus what?
X2.
Respond now. You are the one doing it, not me.
2.
Plus x2 plus what? 3x3. Is that not? Then this one takes S1, slack 1. The second one we take what? S2. Remember that this one completes. Go to the third one. What do you have for? This is what we are repeating.
We are doing magic.
We are not doing magic. Oh. This is what we are repeating. We are only adding S1, S2. The first equation.
Let's take here S1 plus, there is space, you follow that plus. Is it a mistake?
It's not a mistake. I'm coming. It's not a mistake. I purposely leave that. Okay? I purposely leave that, leave the gap. Can we continue now?
Yes.
Mm-hmm. So, but we get how we have our S1 and our S2, right? Hello? You got how we have our X1 and our X2?
Yes, sir.
Okay. If we've gotten that, then we are fine. So the third one is our what? 3x1. That one to do not have our x2. So you will leave it out. Then go to our what? 2x3. Then you will add your what? Third slack variable. Is that taken? Do we get it like this? Hello.
Sir.
Any question? Hello.
I don't understand, sir.
You don't understand?
Yes.
Go. Oh, okay. Okay. Everybody, bring in your attention here. Okay? Bring in your attention. Though this one to prove a bit stubborn, but it is not. Okay? It either looks a bit stubborn, but it is what? It is not. That is what I want us to understand. It looks a bit stubborn, but it is what? It is never not. The first thing is, after we have our stuff like this, let us add our slack variable. We add the slack variable. Please give me your attention. Add slack variable S1, S2, S3 to the constraint. Okay? To the constraint. We are look up. Look up, everybody. Look up. If you don't look up, I will beat you. We are adding it to the constraint. The constraint 1 is our x1 plus 3x3. Okay? Our x1 plus 3x3, add your slack variable 1, change inequality to what? Equality equal to 10. Our 2x1 plus x2, okay, plus 3x3, then you will add slack variable 2 equal to what? Your 40. Are we getting that? Then our 3x1 plus 2x3 plus slack variable 3 equal to 20. Who don't understand that?
This is better.
That is better, right?
Yes, sir.
It is better. You all said it's better, right?
Yes, sir. Yes.
Okay, if it is better. Now, how many products do we have? We have 3 products, right? X1, X2, X3. Under the first one, you will have 1, 0, 0 for the slack. Under the second one, you will have a 0, 1, 0 for the slack. There's nothing like Under the third one, you will have 0, 0, 1 for the slack. Are we together? Hello? Are we together? Are we together?
Yes,
Let us
sir.
see. Who still remember how we do standard form? Who still remember what you call standard form? How we write standard form? Who remember? Hello?
Hi.
Who remember how we do standard form? What is the standard form of 10?
0.1.
Standard form of 10.
0.10.
Standard form of 10. Standard form of 10 will be what?
0.10.
0.10. Let's just say 0.1, right? So that is what we just need to get. So that is why we are having 100. The first one, because we are having 3 variables, so we assume it is in thousand. 0, 0, 1. Then the second one, it will take, this one take 101. 1 will be here for the second one. 1 will be here for the third one. Change the other one to 0. Yeah, this is how it will be. Okay, that is just what we really want to do. No more, no less. This is what we are doing. The first one means 100 is the same thing as 10 raised to power 2. 10 is the same thing as 10 raised to power what? Power 1. That is the standard form of it. 1 is the same thing as 10 raised to power minus 1. Okay? But not to really bother yourself. Just do the standard form as this that I've given to you. That's just how to add your slide variable to whatever question that you might have been given. Now, let us now express it in a linear form. This one is clear. Look, just look at what you want to do. Let me say, formulate, let's say, linear programming model now. Formulate linear programming model. They can call it standard form. Can call it standard form for you, irrespective of whatsoever they might call it. Okay, so just go back to what you're doing, and that is what you're going to do. Your first one, start from your minimize. We are minimizing our z equal to, let's minimize 3x1 plus 2x2. 3x1 plus 2x2 plus x3 plus x3. You will now add your slack variable. Your slack variable 1 will be 0s1 plus 0s2, 0s2 plus 0s3, because the slack must not have anything. That is why it is in a 0. The slack must not have anything. That is why it is in 0. We also call the slack the unused resources under the constraint, or we call it the underutilized resources. It is expected that it is in negative. So please take note of that. Okay? After that, your constraint, just follow that trend straight. Your constraint, let's write the first one. What's the first one? The first one is x1 plus 3x1, right? Okay, yeah, I purposely leave a space here then. I purposely leave a space here then, because that one is not complete. That's why I purposely leave a space. Okay, you can say S1, I put my S1, then put 1S2. Sorry, we are using S. 1S2. Remember that this one will be 100. Then plus your 3x3 plus 0. Sorry, this will be 1. Though it is in 2. OS1 plus OS3. And if you know that you will not understand it like this, just write the equation the way you are given. X1 plus 3x3 plus, the first one will be 1. 1s1 plus The other will be 0. 0s2 plus 0s3. And this will give you what? 10. Do we get this first one?
No.
Remember that's my 100 for slack variable that I did. The first one will be 100. Second one will be 010. Third one will be 001. 1s, 0s, 0s. This is first, second, third. First, second, third. First, second, third. That is what we are doing. That's what we are putting there. Is it clear now?
Yes, sir.
Okay. If it is clear now, then we're good. There's nothing different than the slack variable that we are adding. Aside from the slack variable that we are adding, there's not much more that you requested there. And if you want to complete this x2 so that this one can leverage, you can rather put a 0x2. That is, there's no x2 there, it is 0. You can do it that way too. Okay? If you really want to leverage it, you can just do a 0x2 plus 3x3 plus 1s1 plus 0s2 plus 0s3, everything equals to what? 10. So it makes everything level or leverage. Then the second one, 2x1 plus x2, this one means 1x2, don't forget. You can put 1x2 and you can leave it as x2 plus 3x3. This s2 we put here means that the slack will be in the second one. So this one will be 0s1 plus 1s2 plus 0s3 equal to your what? Your 40. And the third one will be 3x1 plus no x2 is 0x2 plus 2x3 plus 0s1 plus 0s2 plus 1s3 equal to 20. Is that clear? Hello? Hello?
Hi.
Is that cleared?
Yes, sir.
If the answer is yes, this is where I will be stopping. Initially, if they will ask you, they will just ask you to formulate the standard form, which is here. But at times they can say, create your initial. This is the apex that they can go for you. Create your initial table. What is the initial table? What we have here is what we use to create our table. Okay, so how do we create that? You first of all have your solution variable. How many tables you have? 1, 2, 3, 4, 5, 6. Do you see how I was starting my table? 1, 2, 3, 4, 5, 6. So I have 6 tables plus the solution. I have 7. Plus there is something here. I have 8. So that is the table that we are creating. Okay. So whatever you like, you can have your solution at the top. If you like, you can have it down. Okay. Just let us have it as. Let me have my CJ here. The CJ means the solution.